Let's solve the homework. In this problem, the user seems to use inheritance to model a relationship of a car, that a car is an engine and a car is a four wheels. Clearly, the problem with this design is the semantic is wrong. There is no strong or even has a relationship here. The car isn't an engine. The car isn't four wheels. Even if inheritance is going to work well from functionality perspectives, you mustn't do that. Sometimes we can stack things together to make inheritance works well, but this is very, very wrong. The right relationship here is actually composition. You can create a car and then compose it of wheels and compose it of wings, and then if you would like to do something, then you start to use your wheels or your engine. In market, we say a lot, prefer composition over inheritance. Even in this case, we shouldn't use composition because it doesn't make sense. But even in cases where inheritance makes sense, still people would like to avoid it because it makes a lot of troubles. In the second problem here, the core issue with the design is there is an assumption here. There is an assumption here that every mammal should have these functionalities. Specifically, every mammal can give milk, can give birth. Okay. Now the problem is this isn't true necessarily. For example, this animal lay eggs and doesn't give birth, but it's still a mammal. If you try to put this animal here as a fourth class here, you will notice now that this common functionality is now wrong. This is more severe in C++ style and Python and Java. But still, if you put it in your parent class in Python, it's still visible, and still this is wrong. So why someone made this mistake? Simply, the initial requirements were mainly for these three animals. So you thought about these common functionalities in them and designed the superclass to match them. But where is the problem? The problem, you have to validate even future subclasses are going to fit with your current classes, and this prediction scale is very, very hard. So this is mainly the core of this problem here. In practice, you might design a class as a superclass for a bunch of cases that looks like very good and very well, but the real problem happens when you would like to add new classes in the future that doesn't fit with the hierarchy anymore. Think deeper about if your class is good to even potential future classes. Another problem with this sorry, let's move. The problem in this problem here is the problem in general in the description that we explained here. When you start to extend from classes that aren't perfect has a relationship, you end up with simply with a lot of functionalities that doesn't belong to your class, and this is a problem. The example that I gave here you about the robot dog, the problem is a robot dog isn't a real dog, but real dog, for example, would like to go to toilet, but the robot dog doesn't. Now the robot dog has a functionality that it doesn't use. This is going to happen if you make inheritance from a class that isn't as strong, has a relationship, isn't really like when we say circle is a shape, this is a perfect inheritance relationship because all of the functionality of shape are mine. I can use them. But do not make an inheritance from a class that you don't strongly utilize all of its functionalities. Otherwise, people will misuse your class. The last two questions weren't really like an inheritance question, more about design. I'm trying to push you to think in this direction. There is something that we call scalability. When we try to create a website, for example, we don't only think about a website that works well for a 10 or a 10,000 users. We think about something that scale much bigger typically in our days. It's definitely depend on your system. The problem in the two styles of communication that we described is as following. If you design your system such that the application of the user is contacting you frequently to check for notification, this means if we have 10 million mobile users, we are receiving 10 million of mobile requests in a periodical way. This means our server are working too much and we are burning too much money, by the way, for that. And this means we are very slow to handle all of them. And the interesting thing here is most of the time there are no messages. So there are too much effort by our servers and communication and internet that actually end with nothing. So this design is wrong. A better design is the opposite of it. Okay, this is what we call reverse thinking. In this case, only when the mobile game has something new as a notification, he sends the notifications to the users. This means the following: I can send only when there is data, and I can also arrange how I'm going to send them. Like, let's say I don't have to send 10 million suddenly. Maybe in every second I'm going to send only to 100,000 users. That's all. Or based on the priority. So the moral of that is, as a game engine, I now have the control on how I'm going to send my requests. This kind of thoughts is going to change completely your design, your inheritance, your relationships. Do not go with the first idea that comes to your mind. Try to think deeper about the pros and cons of it. The last one here is like a one step before even designing something. It's about like building startups. I worked in a company that was its business model, so I wanted to share it with you. The problem that we have in our system here, or in reality, that could happen in early days of communications, if we have something like N banks and M services, and every one of them is working in an independent way than others, it's expected that every bank is going to try to build the code that matches for the other software. So as a bank, I'm going to communicate with every other bank to build things. And also every bank, every service has to do the same. So overall we have like a 2 times N times M softwares that we are going to build to make complete connections with everything. The problem here, it means with every new bank that the services has to wait some time to build something that communicate with the bank. With every new service, banks has to hire a team to do the connection with the service. And in reality, business doesn't go this way. You have to be faster in the market. You might expand any time to new banks that even might exist. Now here is the business opportunity. As a startup guy, you notice that this is very slow, this is very time consuming, a lot of repetitive code, a lot of time and resources. The opportunity is as following. You are going to introduce a company that will play as a middle player between the banks and the services. Each bank will build only one software to contact the middle layer. For example, the bank it asks to get the bills from a specific service. If the customer asks to pay a bill, the bank verify the balance, and so on. On the other side, each service also will build only one software to contact the middle layer. Now, for the middle layer itself, it will build N software for the banks and M for the services. And it will also have a lot of shared code because it's a single company. So most of the banks will have a lot of shared logic, and most of the services will have a lot of shared logic. It means theoretically we are now building like 2N plus 2M or something close to that software in the system. But there is, as I said, a lot of shared code. Now think in a new bank that existed, or even a bank that as a service I would like now to be connected to it. It's all about connecting only to the middle layer, only to that guy. And if you are already connected to the middle layer, to the middle guy, then all what you need is to pay the middle layer like extra new fees to register in the system. This way, the hassle of building a new communication is mainly now with the middle layer. Only if there is a new bank or a new service, we are just now adding their own code, which it makes sense. But otherwise, we are sharing a lot of functionality. Again, as you see, this has a very nice relationship to the scalability, which is an important concept in software engineering. This system scales much faster than the system that is very independent. And this is a good idea to catch opportunities in market. Most of the startups, you have to observe a need. You have to observe an opportunity. But remember that there is a high failure rate in startups, like maybe 90% or more. You need to do a lot of work, not just elegant technical solution. You need to verify your business model. You need to market it. Marketing play a very big factor. I wanted to share you some thoughts about this kind of ideas. That's all.